Okay, in this video we're going to talk about Unit 5, Objective 1, finding the limits of a function graphically and numerically. So before we can talk about finding limits graphically and numerically, we need to define what a limit is. So we'll say that the limit of a function is the y value that a function approaches as you approach an x value. So the key word here in this definition is that approaches. So when we think about limits, we want to think about the y value that we approach. Not the y value that the function is, but the y value that the function approaches. The notation for limits is we're going to say lim for limit as x approaches some value c of some function f of x. So that would be read the limit as x approaches c of f of x. And again, all that's going to be asking for is the y value that our function is going to approach as we get closer and closer to this x value of c. So we're going to focus on graphs and finding the limits numerically in this video. Then we'll talk about algebraically in the next one. So let's just think about this thing graphically. Let's think about the function x squared minus 1 over x minus 1. So the graph of x squared minus 1 over x minus 1 looks like the line x plus 1. So you can factor out the top. Cancel out your denominator, and you're going to get your graph that looks like this. It looks like the graph of x plus 1, except there's a hole at x equals 1. So there's our graph of our function. So when we think about our definition, we want to find, actually let's think about an actual limit here. We want to find, let's say, the limit as x approaches 1 of x squared minus 1 over x minus 1. So what this is asking us to do is find the y value that the graph approaches as we get closer to x equals 1. So if we look at the graph, this is a complete shift in how we usually think about graphs. Usually when we think about a graph, we look at just the y value. What is the y value when x goes to 1? And in this case, there is no y value. There's a hole in our graph. But the limit doesn't care what the function actually is. The limit wants to know what is the value getting closer to. So if we look at this graph coming in from the left-hand side, it appears that I'm going to the value of 2. If we come in from the right-hand side, it also appears as if we're going to the y value of 2. So that in and of itself tells us our limit is 2. We're getting closer and closer and closer to the y value of 2. Even though we'll never be that y value of 2, it doesn't matter. The limit just wants to know what value are we getting closer to. So we can say our limit equals 2. The other way that we can think about this is if we were to take a vertical line, and put it through the graph at the x value in question. So if we're thinking about that vertical line there, we want to act as if that vertical line is serving as like a pillar or a wind or just something in the way covering up that graph. We don't know what's going on behind that line. So if we don't know what's going on behind that line, and you had to guess what was going on behind that line, you would say, well, it's going to be y equals 2. So if we were to get rid of the line, we would see that there's a hole there, but it doesn't matter because we thought it would be 2. That's what the y value is approaching. That's what the limit is going to be. If we look at the graph the way I have it drawn now, you see the yellow line and the red line. Those are what we're going to call one-sided limits. And those are exactly as they sound. It's just the limit on one side of the x value in question. How we would write that for the yellow one, we would say the limit as x approaches 2, and we're going to put a little plus sign, like a power, it looks like, of 2, and that's just going to say, oh, I have that backward, I'm sorry. We're coming from the left-hand side. So let's erase that and make it a minus. Coming from the left, meaning coming from the negative side. So we're going to say the limit as x approaches 2 from the left, so we get a little a little negative looking exponent thing. From the right would be the same thing, except we'd have that plus sign. And again, 2. So all those things are saying is if you come in towards 2 from the left-hand side, you're getting really, really, really close to the y value of 2. And actually, whoops, those 2's should be 1's because we're going to the x value of 1, so I apologize. So the limit as x goes towards 1 from the left-hand side is going to be 2, meaning as we come in from the left, we get closer and closer to the x value of 1. We're going to get closer and closer to that y value of 2. Same thing from the right. As we get closer and closer from the right, we're going to get closer and closer to that y value of 2. Now, for a limit to exist, we need to make sure that the left-hand limit and the right-hand limit are the same. So we'll put a little star and we'll say a limit exists if and only if the limit as x approaches c from the left of f of x equals the limit as x approaches c from the right of f of x. So if the two one-sided limits are the same, then your limit itself exists. So on ours, the limit of 1 from the left and from the right are both 2. So our limit is going to be the same on each side, so our limit is going to exist. We can also think about limits using tables. So a table of values for that same function that we just had. So f of x is x squared minus 1 over x minus 1. We could get an xy table. So we'll say here's our x values, here are f of x values. And if I put the points like 0.9, 0.99, 1, 1 point, oops, .01 and 1.1 on my table, we're going to get values 1.9, 1.99, undefined, 2.01, and 2.1. So if we were to be asked about finding the limit as x approaches 1 of x squared minus 1 over x minus 1, but we don't have a graph and we have a table, we're going to think about it the same way. We're going to think about what is my limit as x approaches 1 from the left-hand side of my function. So as we come in from the left-hand side, so coming in this way towards my value, we need to say what are my values getting closer and closer and closer to. So 1.9, 1.99, we can see that this is getting closer to 2. Then we need to think, what is the limit as x approaches 1 from the right of our function? So as we go this way towards x equals 1, we get 2.1, then 2.01, so we're getting closer and closer to 2. Since my right and left hand limits are the same, we can say that the limit is 2. So again, notice that we don't care that the point is undefined. Our limit does not ask for the point, it just asks what point are we getting closer to. So that'll do it for this video. See you in the next one.